The Space Telescope's James Webb has discovered something truly extraordinary. Beams of light that look like they are radiating from a city center, shining from a location light years away. This discovery has brought back interest in the possibility of extraterrestrial life. The telescope directed its focus towards Proxima Centauri b, the nearest observed exoplanet to our solar system. Strange and powerful flashes of light were detected. These signals could be from an alien civilization. Keep an eye out for more. Advancements made over the years by both scientists and the general public have captivated people with the idea that there is life beyond Earth. Any evidence hinting at the presence of life has been met with immense enthusiasm. A pivotal moment came when the James Webb Space Telescope presented clear proof indicating the existence of life in one location. While scanning the depths of the cosmos, the telescope discovered an extraordinary event on an exoplanet. Because it was so far away, it detected lights resembling those from extraterrestrial cities, raising the possibility that an alien metropolis might exist on that distant planet. This concept has produced significant curiosity and excitement in the scientific community, because it could be the breakthrough they have long anticipated. It hints at the presence of intelligent, operating civilizations in ways we are only beginning to understand. An investigation into these SETI-like lights, located about 4 light-years away, has amazed and perplexed NASA engineers. How long might they have been visible in space, simply waiting for our technology to progress enough to detect them? David Kipping, an astronomer at Columbia University, has written about the planet where these lights were found, describing it as particularly complicated. Unlike the majority of rocky planets, which absorb sunlight and infrared radiation, this exoplanet behaves differently because of its unique relationship with its star, Proxima Centauri. This discovery made by the James Webb Space Telescope demonstrates the telescope's critical role. Its ability to capture wavelengths in the infrared was essential in identifying the unusual behavior of Proxima Centauri b, which is vital for comprehending the planet's atmospheric conditions. Researchers are planning to continue using the telescope to study the atmosphere of this planet in more detail, with hopes of investigating whether it might be habitable. The James Webb Space Telescope has a high sensitivity to infrared light, enabling it to observe what occurs even on Proxima Centauri b during its nighttime. Numerous other telescopes struggle to detect faint light in the vastness of space, but Webb excels at picking up even the smallest glimmers, making it an ideal tool to confirm if the alleged city lights on the dark side of Proxima b are indeed real. The telescope can detect artificial light in space, provided it falls into a very narrow frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic interaction with its star that significantly impacts its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around its star, it goes through cycles of day and night similar to Earth's. During this time, the planet experiences scorching heat during the day and colder temperatures at night. The range of temperatures on Proxima Centauri b is vast, primarily due to its composition. If the planet has an atmosphere, the temperature difference between day and night would be extreme, hot on one side and frigid on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides valuable clues about Proxima Centauri b's atmospheric makeup. The James Webb Space Telescope, with its ability to image in the infrared spectrum, can effectively examine the global emissions of heat, revealing details about its atmospheric properties. Interestingly, the orbit of the James Webb Space Telescope around Earth allows scientists to make detailed observations of Proxima Centauri b's daylight cycles, which occur every 11.2 days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine if it could support life. Detecting elements like oxygen, water vapor, and methane would suggest the planet's capacity to support life. Studying the passing light through the planet's atmosphere is a complicated procedure. While the James Webb Space Telescope excels at characterizing planetary atmospheres, it is primarily designed for other purposes. Its expertise lies in investigating concentrations of water vapor, carbon dioxide, and methane, but it is less effective at detecting free oxygen, a crucial sign of life. Nonetheless, the telescope can search for other key indicators, like ozone, which suggests a healthy environment. As scientists examine the data gathered, the James Webb Space Telescope's observations continue the hunt for distant worlds. We are getting closer and closer to addressing the question of whether we are alone in the universe. It's important to note that the James Webb Space Telescope can only observe a limited number of exoplanets close to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2027. The ELT is intended to provide a more in-depth look at the atmospheric structures of distant exoplanets, providing clearer and more detailed data on their potential to support life. Scientists are eagerly awaiting the launch of upcoming spacecraft. Meanwhile, telescopes like the ELT and the James Webb Space Telescope remain invaluable tools for exploring distant exoplanets. Despite its limitations, the Webb telescope continues to provide critical information that may change our understanding of what exists beyond our solar system. Researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce starlight interference, allowing for better observation of planets around distant stars. Similar to using your hand to block the sun to see more clearly, these upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might support life. However, this task is far from simple. Stars are extremely bright, frequently outshining their surrounding planets. This brightness makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To address this challenge, scientists are working on several innovative techniques. One such method calls for the use of coronagraphs, devices installed within telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the brightness from the star, making it easier to detect the dim light from exoplanets. Another promising approach is the Starshade, a massive, flower-shaped spacecraft that will fly tens of thousands of kilometers away from the telescope. The Starshade blocks starlight before it even enters the telescope, allowing only the light from exoplanets to reach the instruments. This technique could be particularly capable of observing planets within the habitable zone of their stars, where liquid water and life may be able to exist. However, these advanced technologies require the development of next-generation space telescopes represents a bold step forward in humanity's quest to answer one of the oldest questions: are we alone in the universe? With each new technological leap, scientists are getting closer to detecting signs of life, not just microbial, but possibly even intelligent civilizations capable of altering their environments in ways we can observe across the stars. Meanwhile, the discovery of potential SETI-like lights on Proxima Centauri b stands as a tantalizing mystery. If confirmed, it would suggest the existence of a technologically advanced society capable of generating artificial illumination strong enough to be seen from Earth's solar neighborhood. Such a revelation would profoundly alter humanity's place in the cosmos, sparking philosophical, scientific, and even political discussions about first contact and the future of interstellar communication. For now, researchers remain cautious, aware that natural phenomena sometimes mimic artificial signals. Further observations are being planned to rule out alternative explanations, such as unusual geological or atmospheric events that could produce similar infrared signatures. Collaboration between space agencies, universities, and independent observatories worldwide will be critical in verifying and interpreting the data. In the coming years, missions like the Habitable Worlds Observatory and LUVOIR, Large UV Optical IR Surveyor, are being conceptualized. These future telescopes will be designed specifically to image Earth-like planets around Sun-like stars and to analyze their atmospheres in extraordinary detail. Equipped with the latest starlight suppression technologies and high-contrast imaging capabilities, these missions aim to find the so-called pale blue dots orbiting distant stars, planets that could potentially host ecosystems, oceans, and maybe even civilizations. As humanity continues to explore and understand the universe, each new discovery brings with it a sense of wonder, humility, and responsibility. The possibility of encountering life beyond Earth, whether microbial or intelligent, would not only be a scientific triumph but a turning point for human civilization itself. For now, all eyes remain on Proxima Centauri b and the strange lights emanating from its dark side. With every scan and every pixel of data collected by the James Webb Space Telescope and its successors, we edge closer to unveiling one of the greatest mysteries of existence. We are searching the cosmos not just for new worlds, but for new neighbors. And perhaps, just perhaps, they are already waiting for us to notice them. A significant advance forward in our search for an answer to the most profound concerns of humanity is, are we the only ones in the universe? We continue to improve our capacity to observe those faraway planets that are getting closer and closer to us, to find out if there is life beyond Earth, potentially transforming our understanding of our place in the cosmos. The direction in which space exploration and the search for life beyond Earth is advancing at an unprecedented pace, as astronomers and scientists delve deeper into the mysteries of distant exoplanets. The James Webb Space Telescope is getting ready to usher in a new era of cosmic discovery. It gathers groundbreaking information that assists astronomers regarding the structure and potential habitability of far-off worlds. With each new piece of information, we are getting closer to answering the ultimate question: is there life beyond our planet? The process of discovery, especially regarding Proxima Centauri b, is only the beginning. It could become a major turning point in how we approach research on life from other planets. Being the star system closest to our own sun, Proxima Centauri b has received a lot of research attention for years. However, until now, finding concrete evidence of life, such as signs of artificial light or civilization, was a distant dream for many scientists. The fact that such light has been detected by the Webb telescope only bolsters the hope that we will one day contact other intelligent life forms. This kind of discovery stimulates both scientific interest and public imagination, inspiring new generations to think beyond the confines of Earth's role in the cosmos. As the James Webb Space Telescope continues to observe, it's not just looking for synthetic lights. It is also concentrating on the atmospheres of planets and the chemicals within them, analyzing how these factors could support life. The search for biosignatures, like carbon dioxide or methane in the right concentrations, is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to examine these atmospheric components in a way no previous telescope has been able to, shedding light on the potential of distant worlds to support life similar to that on Earth. One of Proxima Centauri b's most fascinating characteristics is its location in the habitable zone of its star, where conditions might be right for liquid water to exist on its surface. The habitable zone is the region around a star with just the right temperature, not too hot and not too cold, for liquid water to form. This is regarded as an important factor in deciding whether a planet could harbor life. Water is essential to our understanding of life, making the discovery of an exoplanet within a star's habitable zone a key target for future assignments. In addition to discovering future planets that might support life, telescopes will also focus on the complex relationship between exoplanets and their stars. Some planets, like Proxima Centauri b, are tidally locked, implying that the same side always faces the star while the other remains in darkness. This can create extreme temperature distinctions between the two sides of the planet, affecting its climate and its potential to support life. Understanding these conditions is crucial for astronomers when evaluating the likelihood of habitable environments on exoplanets. The development of technologies that can block out starlight, another important source of bright light, is a major step forward in space exploration. Without the ability to block out starlight, it would almost certainly be impossible to observe the faint glimmers of light from distant planets. The coronagraph and starshade technologies are excellent examples of how scientists are overcoming these challenges. By blocking out the overwhelming brightness of a star, these tools enable telescopes to detect the faint light reflected by planets, revealing crucial details about their surfaces, climates, and potential for life. Another exciting development in this field is the idea of direct imaging of exoplanets, made possible by advanced adaptive optics and starlight blocking technologies. According to astronomers, these technologies could allow us to capture high-resolution images of planets as they orbit their stars. These images would not only provide detailed information about a planet's composition and atmosphere, but could also offer a closer look at its surface features, such as oceans, continents, or weather patterns. This type of imaging would represent a giant leap in our capacity to learn about exoplanets and make informed decisions regarding their potential to support life. As we continue to explore the universe and search for answers about the existence of life beyond Earth, the role of the James Webb Space Telescope and future missions will be indispensable. The telescope's ability to detect faint signals from distant planets, analyze their atmospheres, and examine their potential for habitability is changing our perspective on the cosmos. With advancements in technology and an ever-growing body of research, we are on the brink of making discoveries that could alter our understanding of life in the universe. These discoveries not only reshape scientific theories but also challenge humanity's philosophical and existential perspectives. If life is found beyond Earth, whether microbial or intelligent, it would force us to reconsider our uniqueness, our future, and our place in the cosmic hierarchy. Moreover, the search for life extends beyond observation. Future missions are being designed to physically visit exoplanets or send advanced probes capable of conducting in-depth analyses. Concepts like interstellar travel, once confined to the realm of science fiction, are now being studied seriously by leading researchers. Initiatives such as Breakthrough Starshot aim to develop tiny spacecraft that could travel to nearby star systems within a human lifetime. These ambitious projects underscore the growing conviction that humanity's destiny lies not just on Earth but among the stars. Every breakthrough, From detecting water vapor in an exoplanet's atmosphere to capturing a direct image of an Earth-like world, pushes the boundary of what is possible and strengthens the dream of becoming a multiplanetary species. Public engagement and international collaboration are also crucial in this new era of exploration. The excitement generated by telescopic discoveries has spurred educational programs, new funding initiatives, and global partnerships. Space agencies across the world are pooling their resources, expertise, and technologies to accelerate the search for extraterrestrial life. At the same time, ethical considerations are increasingly discussed. What should humanity do if we find microbial life? Should we attempt contact with intelligent civilizations, if they exist? These questions demand careful thought, as the implications of contact, biological, cultural, and philosophical, could be profound. The universe, vast and ancient, continues to reveal its secrets one discovery at a time. And with each new revelation, we move closer to answering questions that have inspired humanity for millennia. Are we alone? If not, what does it mean for our future? As our instruments grow sharper, our missions bolder, and our imaginations wider, one thing becomes clear. The story of life on Earth might just be one chapter in a far greater, more wondrous cosmic saga.